right? And that's why sometimes it's a tricky spelling. You also get stuck, isn't it, guys? So if I ask what is the spelling of a champagne, how many of you guys write it correctly without doing any cheating? So kid is thinking about these orders. You know what is the spelling of champagne? So this is the spelling of champagne, right? If I can be wrong, but I think I know it's a tricky spelling. I think I missed a A, right? No, no. So champagne is right. It's not a easy spelling. So a lot of people have, so I have missed A, I know that, but a lot of people, they miss this. They write chimpanzee. But let me give you the Google search for it. Let me search for you. This is how champagne is. So now if you tell your kid, maybe 8-year kid, they might also struggle. Don't take those spelling bees, those kids who are too good at spelling, they spell like this much long word. I'm not talking about those kids. We are not those kids. We are normal guys. Okay. So champagne spelling is something, right? A tricky one. First of all, champagne word looks like I'll start with S, but that's wrong. It's not champagne, but still champagne is little. So those who have good phonetics, like I think the South Indians have good phonetics than North Indians. They have good. Their language is more difficult. Huh? You guys agree? Than all the North Indians. So the language and most difficult language is Surinese language, or next to Malayalam, right? So Tamil and Malayalam are the most difficult ones. The most easiest one is like Telugu and Kannada. Kannada language. The Kannada who speak Kannada is most easy compared to Tamil and Malayalam, right? Telugu is also fine. Okay, but trust me, the most easy language to learn is Hindi because I don't know what is the reason. It's because of the movies. What is the right reason to say that? Or it will be the language is simple. Obviously, Hindi is most simplest. Hindi, Bengali is also simple. Odia is also simple. But because of movies, Hindi is like prevalent in all the parts of India, even in the northeast. Okay, so I don't want to go into controversy of Hindi and all. I respect everybody's language, culture, rituals, right? And I have a strong feeling that if you're living in Bangalore, you have to behave like a Bangalorean. If you live in Tamil Nadu, you have to behave like a Tamilian. Then you are being true to their culture, right? Don't try to disturb the majority. You know what I mean? So behave and respect. So suppose, right? I don't know how many of you agree, but I'm making a point. So you are just one segment, right? So then you can't be like saying that, okay, you practice what you practice, but don't try to superimpose your concepts on somebody else, right? That's not accepted. Okay. Yeah. So to be honest, in Bangalore, Francis, I don't know, have you been here or not, but Bangalore, everybody speaks Hindi, even the Kannadiga. So that's the reason it's very tough to learn language a little bit. And now in Bangalore, even the everybody is speaking English and all. So you're living in Bangalore only, right? So you know that. So either English or Hindi. If you're practicing Kannada language, sorry, keep saying Kannada, but Kannada is the people and the language is Kannada. So Kannada language is not tough, but you need some intentions. I think my kids will be able to learn it. So I can tell that. Okay, moving on, guys. Guys, working of RNN is not easy to understand. Okay. How to explain RNN working in a simple way, right? So, I feel how many of you are like a avid reader? Like you read a lot of books. I like to buy books. I don't get time to read books, but I like to read books. I have all the good books which I need. So when you're trying to read a book, right? Let's understand. This is a very cool example to understand the working of RNN. So suppose imagine a person who is reading a storybook like Panchtantra or any other books, whatever you like. So every time you read a book, right, you start reading each line and you try to also remember what happened in the previous line. I'm talking about us human beings, right? You're trying to remember what happened in the previous line so that you can understand the next line better, isn't it? And why I'm talking about books like fictional books or Panchtantra ki kahaniya, right? These books are amazing because the story is so tight that you remember things. Like even I remember that Hira Moti Do Bal The because I studied that Hindi, right? Uh, I only read once Chitrakatha, Chimte. There was a movie. There's not a movie. There was a Eidgah or something where the guy buys the, chimta. Chimta, right? In Hindi we call chimta to flip rotis. I don't know. I don't know. Those who have been in my peers to know this story. Idga, I forgot that by Simta. No, yeah, I know it's Hamid. So yeah, Premchand Idga. Yeah, I remember the name of the story. Yeah, so proud of myself. So just imagine, I'm older, so still I remember. So Hamid gives the chimta, that's the tongs, to his grandmother, and she felt shocked and started beating him. Right, but later she got emotional. It's a very powerful story. If you have not gone through the story, Munshi Premchand, he is from my place, right? I don't know those who study Hindi. Those who don't study Hindi or they don't know Hindi, so you can always say that. So he is from North India, UP, Banaras, right? So definitely Godan, Kafan, what a story, man. So suppose you're reading a story, coming back to my example, I got carried away because that's the impact. Isn't it? You try to remember the previous line, what happened, right? You try to sequentially understand what is happening so that you don't lose the grip. It happens in movies also, right? You go and watch a movie. If the story is not tight, the narrative is not that tight, or it also happens for the classes, right? Suppose I keep jumping here and there and haphazard manner I teach you, you will not be liking me as a trainer. Agree or not? Come on. So I try to go so sequentially that you connect the dots. You are able to connect to what I taught earlier with now. That's where the learning is enriched. It's immersive learning experience, right? So when you go to IMAX kind of theater, who definitely they charge a lot of money from you, but end of the day, you like to watch movies in there because the experience is mind blowing. So when I watched the last Batman trilogy, so I watched in IMAX 3D or something. It was 2D or 3D, I don't remember, but IMAX is a different screen. Those who have been able to see, it's not in every place is in India. I'm not sure, but definitely it's in Bangalore. So you watch, it's a big screen, right? 88 or something, and then you feel like you are almost into the movies only, right? So why? Because you're able to connect to the dots. What dots? You can only connect to the dots when you look backwards. Steve Jobs said that, right? So that connecting the dots is all about RNN, right? So suppose if I stepwise breaking down. So let's say breaking it down step by step. This is interesting. So let me draw the analogy. So what is the heading, guys? Oh, sorry, missed to write the heading. Working of RNN. Let's start saying that, let us think, or let us say RNNs as a person reading a book, one line at a time. That's how kids read a book. So before you go and read a book, isn't it? You go in step by. What is step number one? Step number one is you read a word. Go slow, huh? So don't behave like adult. You have to behave like a kid. How does a kid read a book? You will read a word, right? Isn't it? So what I'm saying, when RNN reads the first word in a sentence, it processes the word and stores some information. Like suppose a kid and even adult, suppose you see the word gaslight, and I know you guys are too intelligent, too smart, but anybody who doesn't know what is the meaning of gaslight, don't Google. I know, yes, guys, just Google it in a fraction of a second. That's the power technology has given to you. But trust me, when I was a kid, to know a meaning of a word, it was a tough time. Gaslight. Gaslight is too famous word in the corporate culture. Obviously, what you're saying is like, yes, it's like a gaslight, gas flame, 100% correct. But have you heard the word gaslighting? But there's another meaning to it, which is more important for us, and that's what I'm manipulating. So gaslighting is a verb, right? And generally people do this in corporate culture, psychologically, psychologically manipulate a person over the extended period of time. Manipulate. Where does it happen? Everywhere. Okay, anyways, I don't want to go into the emotional nerve point, right? But someone can also say that in your class, sir, right? You are manipulating us for the extended period of time, right? I know, I'm just kidding. You don't have those kind of ill thoughts about me. I know that as a matter of fact. But you are also gaslighting, huh? The only thing which I don't do is gaslighting, And never say that you can be the biggest data scientist or deep learning guys after I teach you. The only thing I say that what I'm giving you is not easily available. It's tough. Not everybody is doing that stuff. That's truth. Okay, so when RNN reads the first word in a sentence, it processes the word and stores some information. Suppose you see this word in a novel or a fiction book, right? Isn't it you'll try to remember this word? Think like that. Come back to the real thing which I'm explaining, right? So it's like generally people what do, they used to write in a diary. Srini, have you tried this? So people used to write. So I used to write in a small diary, pocket diary, right? Come on. Pocket diary, everybody. So I used to read the Times of India, the Hindu, and used to write. So that's how. So see, I come from village, right? So I come from like not. So I have a very humble beginning, right? So my career is like, I would say I've come a long way. Trust me on that. When I say that, it was not easy for me to be where I wanted to be. Okay. So I used to have a pocket diary and I used to have a dictionary called Bhargav Dictionary. It was very famous in North India. I don't know, it's still there, Bhargava Dictionary. Not like those Oxford and all. It was more like English to Hindi dictionary for me. So I was like trying to learn English without knowing how to learn English. I spent my teenage in my village, right? So definitely, and I know it's not uniqueness about my story. A lot of people have been, or they're still doing that. Trust me. The only turning point for my career was that I went to Kota. That's the only turning point. From there, things changed for me. And the reason I went to Kota because I was one of the top three students in my district. Not like I was dumb and then my dad and my mom sent me. So it's not like I was pushed. I deserved to be there, so I went. But obviously, it took a lot of efforts and money. Let us not go there. It's long story. Okay, so you will note it down, right? You will say, "Oh, gaslight." I learned. I'll write it. So I'll say gaslight. So I used to do it. Why I'm taking this example? That's how RN is doing it. Now it has to do digital. So this is something it has to do digital. So digitally, they will put it into the sticky notes Microsoft provides. For an RNN model, it will put in the hidden state. Can you see this? So for RNN, this is as good as saying the hidden state. Interesting, no? So in the hidden state, they store the information. What is the meaning of gaslight? Are you feeling it, guys? So the pocket diary has been replaced by sticky notes and notes in your phone or Google Keep, right? But still the functionality is same, right? You find a word, although everybody reads a word and they try to understand it, interpret it. So to understand it and store the information in the hidden state, I missed to write hidden state. Thank God I saw this of the model. So I'm taking an example. You read a word. Obviously, we are putting in our brain also, but we are trying to take it for sure, right? Brain can make you miss. Model can't miss, right? You understand? So that's why I'm taking this example of pocket diary. So this pocket diary used to write. I'm damn sure some of the guys are still using this pocket diary. Still, we are living in the digital world. I said that in digital world, now this has become in your smartphone as a sticky notes on your laptop, right? Guys, everybody notes down, right? Some task to-do list, which I'm saying that in RNN sense, it is going to be in hidden state, right? That is, so I'll write a note. That is your way of storing information. So I'll say hidden state is the RNN's way of remembering what it has seen so far. And don't worry that it will only store one word at a time. No, it's not like that. It stores a lot. What is the next step there in the or working? Step two is after reading a word, I would say reading the next word. That's how you read. Just imagine you are like a 5-year-old kid, you're reading a big newspaper. You'll go word by word. Try to close your eyes and resonate with what I'm saying. You will say, Akash, you're making a lot of sense. Because I'm trying to jot it down the feelings of what you have already done. Then what happens in terms of RNN? Then RNN. So I'm drawing a parallel universe or two worlds together that you're reading a book and you're imagining, and I'm trying to use RNN to explain. Can you see the brilliant way of explaining RNN? I don't know if you appreciate or not, but I'm trying to explain RNN while making you recall what you were doing, like a reading a book. You know what I mean? Okay. So then RNN, the RNN moves to the next word. That's how you will do. And it updates. This is interesting. Its memory now by combining what it remembers in the hidden state with the new word it just read. You know what I mean? This combination helps the RNN understand the current word better. You know what I mean? Step 3. So what I'm saying, guys, RNN continues to read. Now, obviously, the kid will not keep doing like one word at a time, right? RNN continues this process. The kid will continue to read the book word by word, understanding it, and if and updating its hidden state each time. So it's like a loop. Every time I read a word, I understand it and update my hidden state each time without fail. Agree? So this way it keeps carrying forward and updating this hidden state to capture the context. That's where funny you get. I know it's a one-liner. Updating this hidden state to capture the context of the entire sequence. The problem is that how long it will go, right? Will it remember everything starting from the beginning of my life? Answer is no. So capture the context of the entire sequence. There are limitations. That's why LSTM is there, right? So don't worry about it. You are in the right direction. But I'll come to that later, right? Before I can demonstrate RNN, how can I say limitations here, right? Right now I can't say limitations. Hold on. Now I'll talk about making prediction. That's the last step in the whole thing. Now your brain is so good. Does it ever occur to you guys? You start making prediction in the next line in the movie dialogue. You start making prediction in the next line in the novel, right? Obviously the language will be different, but you understand what is they are going to say, right? Have you ever? It has ever occurred to you? Do you also try to do it? Like you must be thinking what Akash is telling or what you are telling, and I'm reading it. So yes, that's how brain works. And look at this, how good they have done it. You should be proud of these guys who have built this. We have not built it, so we are just the consumer or the user of this technology. But at end of the sequence, right? RNN uses its final hidden state, which basically used to predict. Now they are not doing so when we are reading a novel and all, we tend to predict, but we actually also read. So it will predict the next word or classify the sentence or perform other tasks. Sentiment analysis is the task. We will do it, guys, here as a use case here, or perform other tasks like sentiment analysis, one of the biggest use case of RNN. In social media world, sentiment and perception is everything. Agree? If you're not happy with me, even I'm doing a great job, I will be replaced. You understand what I mean? Because you don't have the true sentiment about me. You have a false narrative in your head because someone is impacting me, because they are influencing. That's called gaslighting. Psychologically manipulating you. Okay, guys. So yeah, I think this is just a very simple way of explaining how does RNN work. So whenever you're designing a neural network, any one of it, MLP, CNN, whatever, right? First of all,
Yes.
let me tell everybody there are no hard and fast rule for determining the number of neurons in a layer. But it has more to do with what kind of infrastructure you have. For example, iris data set. There are only 4 input features. I think anybody would take all the input variable, input neurons, right? So what we are trying to say that ideally, if it is not like 5,000, 6,000, and hundreds of thousands of neurons, means input variable, you don't need to think about importance. Ideally, it will not be in real world. Okay. But in
Okay.
CNN, you can have like 300 by 300, which gives you 90,000 pixels, right? So 90,000 inputs are there, and that's why we do downsampling also, remember? Using the
Yes,
max
sir.
pooling and all. So yeah, that's there. But ideally, you see that we try to start with the fully connected, means all the inputs we will take in the input layer and going forward. Okay. The other thing you have to keep in mind is that try to do the scaling. So suppose your input ranges are in some data points are like in thousands, some data points are like in hundreds, some data like in 0 to 1. So always is better to standardize or normalize your data set. That helps your any neural network to converge faster. That is another best practice in the input layer I'm talking. Okay. Now, how many hidden layers we should have? We should have one, we should have hundreds, we should have how many neurons there? So there's no rule as such. Again, I'm coming to that. But idea is that at least the thumb rule says that you should take input neurons and output neurons ka average. So for example, if we have, generally we use, and again this is like an empirical formula, that suppose I have 700 neurons coming as input and I'm dividing. So take that example now, MNSIT data set. So 784 inputs, output was 10 classes, right? Okay. So anything which is average of these two guys, okay. So, you know, 2/3 size of the input layer or half of it. So 350 neurons you might be having in the hidden layers. Now you know that I have not taken 350, I have taken 8 or 10, right? Because I don't have the power, I don't have the infrastructure. But ideally, I feel that for a MNSIT data set, people start with 16, 32, 64 neurons and they stop it because of the computational challenges. But ideally, in the best practice, we have a big machines, you can take 50 to 200 neurons. Again, I'm saying there's no rule, there's no formula someone can give you that, okay, these many neurons you have. But it will only come with the right set of questions. Suppose I have a big machine, I would still try with 50, 100, 200 neurons. If I have a small machine like my normal laptop, I'll not be able to go beyond 8, 32, 64 max. Okay. In a hidden layer. Because it's just sequential transformation, right? So you can have more hidden layer. But within a hidden layer, number of neurons, you have to be very smart about it. Ideally, I start with 8 neurons. You will see 8, 16, 12. Okay. The best practices is that don't do underfitting, don't do overfitting. How will you know it? You will only know it when you run iteration. There's no other shortcut. That's why you have to keep iterating, keep thinking about it. Okay, I know there are some website they will give you a formula or something, but again, I'm telling you, reading a lot of research I have done, nothing works like this. You have to do some overfitting handling, you can do regularization, you can do dropout and other stuff. So we have already covered that part. So, you know, images can be noisy, and I think I want to show you one quick screenshot. So how does an image which can be noisy looks like? I'll put it here. So this is your having noisy image at sigma 90. And so, right, this is the clean image. You see there are a lot of jittery or noisy dots, right? But you click this image and then you denoise. So that's why I have to go into detail to explain that you have come from 9.05, 9.49, right? This is your power of signal to noise ratio. It's communication, electronics. Background guys would know more. And you're using BFS CNN, right? Your image, which was full of dots, as you can see, it gets really better from here. If you go here, right? It's almost as close to, close to this part. Not like 100%, but at least it gets smoothened out, right? This is
Yes,
called
sir.
power of signal to noise ratio. You can Google about it. So I have done BTech electronics. So this is power, signal power to noise power. If it is more big number, your signal has less noise, right? Means good signal. It's like a good signal. Signal is as simple as that this image. And if this is less than one, means your noise is dominating. Much less than one means you have bad signal. In this case, it means you have a good image, or here you have a poor image, or you can say a noisy image, or this could be your denoised, or I would say less noisy image. So that's why if you guys focus 9.05, it's almost three times, right? Three times. If it would have 27, three times the quality of image is increased. But you will hardly see any difference between these two. So now again, they're using a technique called BFCNN. So you will ask me, what is Akash BFCNN, right? BF is bias free, so obviously I can't go in all the details. Okay. Let's talk about RNN architecture. You know that RNN architecture is going to be from your neural architecture. Neural network architecture, it's a feed forward. Let me show you. This is a feed forward. So you go from one layer to another. So I'm excited about that. This is your forward propagation, you can say, right? And you know that you have another layer. So this become input for the next one, and likewise. And finally, you have an output layer. You know what I mean? If you go back, it called backward propagation. You have seen this in neural network, CNN. You are going to do forward propagation or forward pass, you predict. This is your prediction phase, right? So during the prediction phase, right, there is no there's no context getting about, right? It always try to take a new word and understand the context better. But since there is no sequence, there's no order, and in forward propagation, it keeps taking the output and making an input in the next, and so on and so forth. So ultimately, it doesn't do anything like this, right? In the forward propagation. In the backward propagation, right, that is your obviously backward propagation and forward propagation, they are a little bit different. Why? Because you train while you are updating it, right? You go back and update your parameters, and the training phase is complete. Ideally, to be honest, it is combination of both. So if I say forward plus backward, together the combo thing makes your training happens. But when you are doing prediction, right? When you're doing prediction, right, it doesn't do anything. It just takes the data and predict for you, right? There's nothing you fine tune in the output. So far with me in the neural network. But what RNN does, RNN has internal memory. And let me show you this. In architecture, I'm saying. So if you see, I have already written few of the things. So if you compare, this is a feed-forward neural network, guys. I'm just saving some time. And if you observe, I have highlighted something, this part. Can you see there is a circular loop on this node itself? I think someone also wrote that. So this is what helps you to do. It helps you to store in the internal memory. Internal memory. Do you see that? You can't do this here, anything like this, right? There's nothing like this. So I can say that no. I can say that there is no internal memory. So that is the biggest difference in the architecture itself, right? Okay. So what I'm trying to say, my dear, is something which is having everything. It has a hidden layer, but you know, it also use output to store. Okay. So I'll show you one architecture. Just pay attention. I'll explain everything here. That's why I'll not go into too much of mathematics because trust me, mathematics is super heavy here. But what I'm trying to say, and you have to pay attention to understand. So I'll just write one pointer. RNNs allow previous outputs to be used as inputs while having hidden states. This line has a lot of depth. How we will see. I'll try to show you. It's not easy to show you within the box. Here, understand here. So here xt represents sequence of inputs. Sequence of inputs. Okay. Now we will also break it down that what do we mean by this. Sequence of input, okay, but what do you mean by sequence of input? It is contextual. Contextual. Depends on the context. Green boxes at the bottom denote the input sequence. Sequence. What yesterday. Now we are labeling as what? So this T is like what? x1, x2, so on. So green box input sequence. This sequence can be as simple as that. Listen to me. Input is a sentence. If I say input is a sentence, then each x t could represent a word or a character. Are you getting? Could represent a word or a character. Right? Sequentially it will go. I'll also take an example. Don't worry about it. So now you understand. I will elaborate this diagram now. Moving on. Second is what? Hidden states. Hidden states. See, hidden state will be there, right? Hidden states will be there. Hidden states, we are saying that the blue, can you see that is what? Let's say in the diagram, blue rectangles in the middle represent the hidden states. So let's understand the game of the land, right? So at least you know that this is the place where they will store the memory. So think like this. These are all your x's, right? So this guy is going to store the memory. I meant to write here this side. So all this part is going to store the memory in this diagram, which is in terms of this architecture is the same thing. So what I'm saying, these hidden states maintain the memory of the. So let's understand the first. What I'm saying that each hidden state A T carries the information from the past. Past inputs up to the current step T. Okay. So what I'm saying is that in a basic RNN setup, attention, the hidden state AT is computed, right, at any point T is computed using the current input x of t and the previous hidden states. And what is going to be the previous hidden state? Now you guys are getting hang of it. T minus 1. Then you can put t equal to anything, 1, 2, 5, 6, 7. So this is how sequentially it is capturing, right? It's not jumping to it. Okay. This is your second thing in that architecture. Third is what? Outputs. Notation is telling you loud and clear. I mean the green, the pink boxes. So pink boxes are like your output. Okay, I'm talking about this one. Here actually they are calling red boxes, but that's fine. So let's write. So red boxes at the top denote the outputs of the RNN at each time step. Okay, labeled as Y1, Y2, Y3, and so on. So I'll show you again. Look at this architecture. Now it makes sense. So what you're doing, guys, apply your AT-wala method. So Y1 is going to be what? Taking the current input and the previous hidden state, right? So it will be what? X1, taking the previous 1 minus 1, A0, getting the Y1, okay? Then this Y1 is going to get stored here. So when the next time you do X2, it will come A1, taking the previous and using X2 as the current input. It is already capturing what happened here, right? And telling you this. And then it keeps moving on. Make me? And that is, I love ice cream. At least everybody loved ice cream when you guys were kids, right? Let's say this is a sentence. Hello. See how, okay. So I love ice cream. Ice cream anymore. Yeah. Okay. So the first thing, guys, if you see here, what is say cream? Guys, it's coming from left to right. So processing the first word, which is I. First word I. What will happen here? Now to process this, RNN will start with some initial hidden state. Generally, it will be set to some standard random values, right? You remember that? It can be as simple as zeros also. Then I will be passed into the network. RNN processes the word I and updates its hidden state A1 based on the input I. Okay, so I'll write a few things so that you don't miss it later. So I'm saying, guys, number 1 point, RNNs starts with an initial hidden state, usually initialized to zeros. Coding, you will see that, or random values. Guys, you really need a hidden state, right? You need A0, okay, for the first input. Don't worry. The first input I, it will go to the network. First input word. What is that word? I know it's one character, but you are going to pass into the network. Now network processes this word. RNN network will process this word, right, using this blue box, which is your what? Remember, no, blue box is your hidden state. Using the initial and the input, it will process it. That's how it works. And store it in the memory. Now this seems like a black box for you guys, I understand, and we have to keep it like this. RNN processes the word I and updates its hidden state. Now you might be curious that I'll try to go a little more deeper, but I am skeptical about it. Need to keep it as per the syllabus. So you're going to make this learning happen. So we say that hidden state. Sometimes no literature also write A1 or H1. So both are correct. Don't worry. H for hidden, so that's why they use H, but people also use A. I'm using A, so I'm. The next part, guys, you tell me. Next word will. We are not worried about space here as of now, Masrad, to answer your question. And in NLP and in other tools, there are ways to ignore word spaces and few those things. Processing the second word. What is the second word? I think love, right? I love ice cream, so love. The whole word will be getting into the model. Sequence is very clear. I'm just explaining the sequence. Second word love is passed into the network, which is your RNN network, along with the updated hidden state. Now this is something tricky and you have to understand. Guys, remember when I started the hidden state, it was initialized to random values of 0, right? See, usually set to zeros or random values. When this first process was done, hidden state got activated or updated with the word I. Clear, no? So what it's saying, second word love is passed into the RNN along with the updated hidden state, and that is your H1. Or we also write A1. So what I'm saying, I'll go and see in the show in the diagram. Here you had brought I, good. This is your love. So what happened? I is already being captured here. Now the next time this I will be going along. Please pay attention. Or I'll use different color so that you don't miss on it. Are you able to follow what we are doing, guys? This I is already captured now. It will go there. So next time when you go here, it is already having what it with it. What is already updated in there? I love, right? So then the next time you will see, it will see ice. So I love ice. When you go next, it will become I love ice cream. Clear? Sequence you are able to understand. I know you have tons of questions in your head. How does it do it? What is the science behind it? Ideally, when I say science, it's the maths, not the RNN uses the hidden state H1 or A1 along with new word. And what is the new word we had, guys? Love. And this to produce, alter the hidden state, right? So to produce a new hidden state called H2 or A2. Cool, no, guys? Thanks. You can say processing the second word, moving on to the third word. But this is how the model updates. I told you. And the next will be processing the final word or the fourth word. S2. S2 has is I love as the word. When you go to this, you will get H3 or A3, right? And you will get I love ice. When you move to the fourth one or A4, you will get I love ice cream. So the whole context is getting captured. The question is that how does RNN hidden state understand I love or I love ice cream? That is something we are trying to understand a little more in detail. See, obviously there's a mathematical scene below under the hood. There's a concept of word embedding. Have you heard embedding? Now I'm trying to deep dive, my dear. So there's a concept of word embedding or semantic or sequential. Let's say you're trying to write a journal. So you wrote something, but then you slept because it was pretty late in the night. Again, you came back and continued, picked up. So isn't it when you did something here, till here, it is all stored in the journal, which is your hidden state. And then you again put your input from the mind or your journey and adding further. But what I'm trying to say, when you say I, you give a letter I or a word I love, what it converts into the vector in NLP also. So it's like converting the characters into numbers. Vector, embedding vector. So I will also write, else you'll forget. So what I'm trying to say, how does RNN process the word I? And in NLP, I will be literally doing this. You will understand. So processing the word I, what it does in this, it transforms, it's a transformation, right? Transformation, the word I into an embedding vector or embedded vector, which is basically in layman term numerical representation. Right, our algorithms, our machine are all 0101, right? It does not understand English, Urdu, Farsi, Tamil, Telugu, right? So it has to be a numerical representation. What is this is does? This is the first thing it does, that it converts into a numerical representation. The beauty of this numerical representation is that it captures the semantic meaning of it. Now, what is the word semantic? NLP. Semantic meaning of the word I. Obviously, we know I means मैं. I love ice cream. मुझे ice cream पसंद है. So, semantic meaning of the word, in this case, I. What is the meaning of semantic meaning of the word I? Semantic means relationship between the words, right? So you must have heard about lexical semantics. So it's like, denotation, connotation. There are a lot of things, to be honest. But suppose, you're trying to understand what with the context is called semantic. I don't like ice cream. It means you just not only know the information, you also understand that person does not like ice cream. And if he tells that, I do not like ice cream and some reasons, you know that the person does not understand does not like the ice cream with this reason. So you understand the whole context, yes. Because it's very important that context is here. I'll give an example. I walked into the bank. One sentence. So NLP, well, NLP started, guys. So now I think you'll be feeling happy about it. Sentence 2, I walked on the bank of the place. Now you understand the same word bank has two different meanings because context is changing, right? One is your financial institution, right? It's like more like your bank, PSU, private, but it's an institution. And this means side of the river. Side of the river. Agree, no? So this is what we mean when I say captures the semantic meaning of the word. Although I here is very simple, there's no confusion, but this is what you have to see. Semantic, I'll also write one liner so that you don't miss. Semantic refers to the meaning and interpretation of the word, meaning and interpretation of the word, and it can be not only word, it can be words, phrases, sentences, and symbols too, right? I'll tell you another example, right? Brick in the wall has one meaning. Brick in the wall. It's like we are talking about there's a wall and right, and there is a brick. So brick in the wall, right? You understand what I mean? A bricks in the wall. But if someone like one sentence, we are we are just brick in the wall. You know what is the meaning of this? Now the two things have different meaning altogether. Trust me on that if you're not believing. Very good, Francis. So we are like one brick in the wall. We are insignificant. We are like one drop in the ocean. You know what I mean? One brick in the wall. So now this becomes like an idiom. Very good. This is just like a phrase. Meanings are too different, right? This is actually meaning brick in the wall, right? This is actually meaning brick in the wall, but here things have changed. Why? Because it has different semantic meanings. So we're saying that semantic refers to the meaning interpretation of the word, sentence, and symbols, the context. Okay, I'll highlight this. Good. So I'm saying that processing the word I'm saying that processing the word converting it into a, so model tries to understand the semantic meaning by converting this into a numerical one, and there is a lot of going behind the scenes, so we can't go into all the detail, but are you getting the functional understanding of it? That's my maths. Once they're processed, they know that the model knows that I is like a pronoun. Hello? What is I in English grammar? Pronoun. So model knows that. So I'll just also write that. So once hidden state. So now once the processing is complete, once processing the word I is complete, the hidden state H1 or A1 now holds the information about the word I. Now this is a very first word, and it can be as simple as like, it has not a lot of meaning to it, like recognizing it as a pronoun. But it's a good identification, na guys? And model would be able to understand that pronouns are generally the subject. Hello? Pronouns are generally the subject of a sentence. Come on. He, she, I, right? These are all pronouns. You know, he, him, her, his, her, right? He, she, his, her, and him. Okay. Subject of a sentence. Now, guys, those know grammar, they know there is subject. I don't want to teach grammar. You can refer to Wren and Martin. So what we are saying that now model also understand, my dear, that this sentence which I'm going to look at in some time is going to have a sentence. So in essence, I'm saying in essence, now your H1 or A1 is now aware of the fact, see this is how the model is learning, is now aware that the sentence has a subject. This is a big learning for the model. Now again, you can question me, but how is it learning? That's what I'm trying to not go into, and it's a little difficult. Now, once you do this, now I will process the next. Yeah, how is the mathematics? That's right, and that's what I'm trying to avoid, because see, I have some. See, to be honest, I know exactly what happens, and trust me, I know because it's all my interest. To be honest, I was not taught. Processing the word love. Let's move. Let's spread the love here. Okay. So the moment you will bring love, already it knows that you have, and subject I, and the next word love will make that the subject love something. Come on, think it. Take it like a how to say. Think like you are a machine trying to learn something. So I is the subject. That subject I, which we are referring to, love, is what? Something will come. But what is till love, right? So when the next word come love, again it does the same thing. I'll write it again because so that I'm completing it. So when the RNN receives the second word love, it transforms obviously this into the word love into an embedding vector. Again, the numerical representation. Which is your x2, right? Which captures the meaning of love. Okay. Now, next thing happens. This is the first step. The next thing which happens is what? It also updates the hidden state by combining x2 with the hidden state, or I have been also writing a1 with the hidden state, and this is your previous hidden state. I'll write in bracket. Already holds information about I, which already holds information about I. Very good. You guys are getting hang. I know. At least I can give you what is the maths looks like, so that you don't say that Akash did not tell any maths. But I'll tell you the maths. How does it look like? The first update we did, it looks like this: h1, or you can write a1 equal to tan hyperbolic. So the activation function we use here is tan hyperbolic. Weights hx multiplied with input. This is what we do, weighted sum. Weights into the input plus WHS, HH or HS, how do you pronounce? H0 plus BH. Don't worry, I'll explain the terminologies. Here is what? So here WHX is the weight matrix. But guys, I'm just telling you for your curiosity. I was trying to avoid this. That connects the input to the hidden state. Okay. And you can clearly see, right? H in hidden state and X is what? Your input, right? Observe this, guys. Cool. What is your WHH? This is like weight matrix connecting one hidden state with the other, right? So weight matrix that connects. Both are H means hidden state, which means connecting the previous hidden state with the. Can I say that, guys? It's important now that you have access to current as well as the older. BH is the bias term, most easy term to identify. Bias term, and tan H is another easy term, and that is your activation function, tan hyperbolic. So this vector, this mathematics will handle everything for you guys. Understand? Let me write here only. And it is your hyperbolic activation function, tan hyperbolic activation. Now, for the second layer, it's the same thing. Now look at the beauty. You will understand very fast. So this is going to be your hidden state, H2. Come on. H2 or A2 equal to, so tan H, again hyperbolic, WHX input, right? Second input plus, what is your second input? The word love, the embedded vector love, WHS dot H1 plus BH. See, guys? So if you remember, here I had written this H0 if you're paying attention, my dear. See this. So you're updating the activation function, sorry, hidden state, and you keep adding this. Now, can you see that? It's take a pause and very good, right? So does neural network gives you this functionality of embedding one input to the other No, right? There's no way you can. Now question from Francis, why tan H is used as activation function? Because you need to understand number one, the range is from -1 to 1. Okay, so it can take both negative and positive values, and you know that text can be also positive and negative sentiments, right? So definitely it helps you to handle the zero center data very well, because I don't like ice cream can be another word, right? Sorry, another sentence. I do not like ice cream can't be on the same side as the I like ice cream. It's opposite, no? It's like positive sentiment and the negative sentiment both are there. If you take sigmoid or some other activation function like that, then it will only be focusing on the positive side. Oh, you don't like ice cream. Oh, you like ice cream. So even someone is saying, I do not like ice cream, you will make it positive and understand that, oh, he loves ice cream. You understand what I mean? So it is important that tan H is there to handle the positive and negative values. That is the biggest reason. Your question, Francis, why do we use, writing proper English, tan H as the activation? So now answer is, I'll just write the answer. So tan H function ranges from -1 to 1. I hope you know the graph. I'll show you in a moment, from -1 to 1. Okay, which means it produces both negative and positive values, which is advantageous, which is an advantage, or which is advantageous it centers the data around 0. So neutral comment will be around 0, center the data around 0. So neutral comment will be around 0. Positive comment will be on the positive side, negative will have negative side, right? And because of this very clear-cut demarcation, your model becomes better. So making optimization and convergence faster. It is very easy to find the appropriate answer, guys. Come on, yes or no? The whole idea is to make the model converge faster, obviously accurate. Activation function is a lot to do. If you take sigmoid squeezes between 0 to 1, so it's more like non-center output, and that can lead to slower convergence and also the not the right fit for something like RNN. Yeah? So you can clearly see that the range means y, by the way. Range is y, okay. Domain is x. Those who are little weak maths. So range means y values. Let me write here. Those who are good in math, they will understand what I'm saying. So what is the range for sigmoid, guys? So range for sigmoid, you can clearly see between 0 to 1. See, the lowest value is 0. The highest value is 1. I have this power, right? Why am I not using it? Come on. See? So 0 to 1. This is for sigmoid, right? What is the range for tan h? -1 to 1. This is your sigmoid. So why I keep showing this nice charts and all, my dear, because you can see the beauty in the concepts. So obviously it is a better data, right? So now what I'm saying, guys, because of this, what I'm saying now, guys, because of this, write a note. If someone asks in the interview, you just that. So that's the reason RNNs often use tan h. It's not like this is the only function you should use and all the time, but it's one of the most preferred choice for modelers, as the activation function as they need to capture what RNN model need to capture, which I've been telling you guys, both positive and negative relationships. This is reality. Life is not always rosy. It has also thorns, right? A lot of thorns. Both positive and negative in sequential data. Like I said, no. I love ice cream is one sentence. I do not like ice cream. It's another sentence. This looks like positive, those who are ice cream lovers. But the moment you see this do not, you know that that person doesn't like. So positive and negative. Color coding, I did it. Now the next topic is recurrent. But before I go there, I want to just give you a summary of why recurrent networks are so special, right? So now summarizing the RNN. Okay, coming on. Internal memory. So This is important. This is the key features, right? Key features in contrast with what? How is it different from neural network? Because this is also neural network, right? Recurrent neural network. But how is it different? Someone can ask this question, like one guy can ask in the interview. So I'm summarizing this because I have taught or talked more from neural network. And when I say neural network, like all of it, ANN, CNN, so I should rather write for other neural network. Obviously, it has its own swag. India is losing match here, one after the other. Okay. So RNNs have an internal state. We just saw that, the hidden state. That allows them to retain leverage information from previous inputs, which is crucial for tasks where context matters. Okay. That is why internal memory is one of the coolest feature it has. What is it? Sequential data handling. It doesn't handle data at once. So, picture. So RNN, what you're asking, specifically designed for working with sequences. Okay. Making them ideal for applications like speech recognition. This is your summary. You already have been taught. Sorry. Language modeling, topic modeling. These are some real use cases in the businesses. As a matter of fact, time series analysis also. For time series analysis or models, you can. Okay. Now, contextual understanding. Does your neural network or CNN understand context? No, no way. So RNNs can interpret in the context of prior information. So RNN is known for contextual understanding. When I'll do a model, I'll try to show that the kind of promise I have done to you guys, done with you guys, which is essential for understanding the meaning and the flow natural language tasks. And flow in natural language tasks. This way. And last but not the least is dynamic adaptation. So RNNs continuously updates internal states. continuously updates internal states, allowing them to adjust to all patterns within the sequence. There are different versions of RNN architectures, and there are different types of RNN, guys. So let me show you one by one. Can you see it? What I showed you at the first thing is your one-to-one. You see their pace here. See, it's one-to-one. This is your traditional, neural network for the RNN. I did write recurrent neural network. As you start thinking, oh my god, this is a neural network. No. Okay, one to many, right? One to many. So one to many is used when you give one input, right? You give a single input and network result in numerous output, right? So generally this is being used in the music with me. So more. So you can clearly see that I'm giving just one input. See, this is the input. Let me highlight. This is the input and output is getting as an input. See, so that's why you're getting only one input and many can generate, many output can be generated. Okay, that's the point. Now, let us think of why. So this is very simple. This is something I've already seen. Any idea, any thoughts around one to many? So this is the new. So how does it help? Sa is a sur, right? But that can to make multiple music, right? Musical notes, different. So what it can do is just give input and it can create a whole sequence or patterns basis that one input, leveraging the training. So what I'm saying, a musical note, trust me, I can't show you as like a demo, but a neural network in here, the RNN is given an initial note or theme as input and then it generates a full sequence of musical notes based on that input. You can ask me, Akash, any Google Magenta is an, so you can give a short and then right can create the beats class. So I give you the example, you can go through it later in your own time, and if I find time I can show you that. So there is something called MuseNet, and there's another one, Magenta. It's not the color. Magenta use neural networks. Mostly we are talking about bunch of neural networks. That's why I'm writing neural network to expand on a small piece of input node. And create longer. Moving on to many to one and so another two architecture, guys, see. So many to one is, so now if like you give me a feedback, right? Suppose someone is very into, they'll write it that trainer Akash, feedback. So now in this, so many inputs you can give, right? Many. So you can give many, writing full on about me. Now overall, it can be a, okay. But ultimately, guys, it will be what? Out of 5 star, either you will give me 3, so you'll say 3 star. Are you getting what I'm saying? Or 4 star if I'm lucky. Okay. So what I'm saying that ultimately it will come as a score out of 5. Let's say it is 4. So isn't it not? Are you giving a lot of inputs, so many inputs, finally translating into that he is good or he is very good, right? He is bad or he is very bad. Agree? So you might write 100 inputs, words, 100 words, but finally it will conclude to this one number, 1. Got the example? Now this is very named entity recognition. So named entity recognition is a common task in natural language processing. What is natural language? The language we speak is natural language processing. It's a big area. So this named entity thing that involves identifying and classifying and in text. So entities are all in text into predefined categories. And I'll show this in NLP, such as names, a person, organization, location, dates, many more. An Indian name, right? Organizations, locations, dates, and many more. It has a huge list, by the way. So I'll give an input to the model. I'm saying that Apple is looking to buy. Apple is looking to, Apple Inc. is looking at buying UK startup for $1 billion. It goes into RNN, this input, RNN model. The output you will see the same sentence, but it will be able to classify real quickly if the model is trained. It will say Apple Inc. It will know that it's an organization because of the database information. Looking, buying, right? It will know that this seems to be actions. So Apple is doing some actions, right? It will also know UK means it knows that it's a location, it's a country, right? It's a country. That's what it means. It understands line by line, guys. Startup, again, it will say startup means what? It's an organization, some organization, but the name is. And the language thing we can, and if I say this is $1 billion, so billion is the amount. So it knows that it's the money, and it also knows that what is the currency, because the model has been. This is how does the output looks like. See, person Steve Jobs, organization, it knows that Steve Jobs is a person, organization is Apple, location is Cappuccino, Chipitino, I don't know how to pronounce, date, third, time, money, percentage, product, event, Golden Gate Bridge. You understand? So it understands a lot than you can expect, right? So that's why Google Translation, I'm talking about the Google Translate. So if I say something in English to Hindi or English to Tamil, the number of words for the sentences I have spoken will be different in different languages. Agree? I'm talking about the number of words. That's why it's called many to many, but we don't know is it going to be equal or not. So I can give you a scenario. So people learn French. A lot of people are learning French to stay in Europe. So someone is trying to learn English to French. Okay, so how does it work, guys? What it does, so there is a model. So sequence to sequence, it's called sequence to sequence, which is SEQ to SEQ, model with attention. Yesterday I was also talking about attention mechanism. Processes, obviously it is out of your syllabus, and input sentence in English, but understand the use case so that you have awareness, and generates an equivalent sentence, not equal, equivalent. Why I'm saying equivalent sentence in French, the meaning and the context will be same, but it will be slightly different, right? It's not going to be exactly same. The same feelings you can't get. So if I try to speak Kannada in Bangalore, I can never be like Kannadika because they feel the language. I will be just speaking it. Okay. That's what I'm saying, no, Srini, you have to understand the feel, and that's where the machine will not feel. It will just translate for you. You feel and speak. It's not trying to speak for you, right? That's why if you see all the AI robots, they just speaking. The encoder reads and understands, right? So there's an encoder and decoder. So encoder reads and understands the input sequence, and decoder generates the corresponding translation. Word by word. Here in this particular use case, tone is not a thing. That's like Google transformation, right? Sorry, Google translation. It just generates the word, right? So if I say, can you try the same thing here? See, I can't show you this or can't make you listen, but if you try this, it will just read. There's no feeling. I love watching, right? You will see that it does the same thing without any, it's just a translation, my dear, okay? It doesn't give you a feel or vibe. Agree or not? Just do it and tell me. Now tone is coming with AI and all. Google Translation is like one of the best use cases in the world. Yeah, I've already talked. Let's talk about limitations of R constraints. So one of the biggest constraint, which is a topic for the interview, please note it down, and that is called. That's I'm next session, but I'm giving a teaser. Explain. But this is one of the biggest interview, one of the top-notch interview question. If you can Google it, you will find vanishing and exploding gradient problems, right? It is really an issue. So what is the issue you will see in this model during back propagation? It's like, okay, the gradients of loss function with respect to earlier layers, gradients of loss function with respect to earlier layers become extremely small. If something is vanishing, means what? Gayab, right? In Hindi. Become extremely small, right? That's called gayab. Or it can become, so, it's like very small, that's a problem. Or it can become extremely large, right? That's called exploding. So I think I am 6'2". I've exploded in each direction, 3D direction, XYZ. Okay, not good for my health, but definitely I'm exploded. Someone who might have lost weight and that guy might have vanished. Okay, so both are problems for us, isn't it? We don't want that. We need balance in life. This is the biggest issue, and this will only happen. Let me also tell you, this issue is not like it happens all the time. This issue comes when you have long sentences. Sometimes I keep talking, right? Or there are people who will, suppose they want to go to somewhere, they will just keep talking. This issue is especially when someone using a lot of words in their vocabulary, right? And there are people who will just say something in, right? They'll just give some signal and they will understand. Guys and the girls, they communicate differently. So this issue is mostly with the girls conversation and with the guys conversation, or bhai bata kya, that's it. You know what I mean? So I'm not trying to be sexist here, don't feel, but nowadays even guys are talking talkative a lot and all. I am one of the talkative guys, so don't take it otherwise. But I'm just trying to make you remember or give you a mnemonic to remember this. Now, what happens if you keep giving long sequences is right? The model needs to. So this is the issue. But this is the issue? What is the impact? When the gradient become very small, let's talk about very small. Is there any intelligence added in the next layer? So earlier layers receive very little information because there's no intelligence, right? Very little information during training. So your train model is crap. So all the earlier layers, they receive very less information during training, making it difficult for the network to learn dependencies from earlier steps. Make sense? From earlier time steps. Now I know you might be thinking in your head, how little or small gradients are related to these. Now, second point, which you guys were telling, maybe might have done some Google or might have known from your earlier or prior information, RNN has inherently difficulty with the long-term dependency. Difficulty with, that's a second important drawback or limitations. So long-term dependencies. So what do I mean by that? I mean by that, the issue is here, RNNs struggle to capture long-term dependencies in data. So what we are trying to say, as the length of the input sequence increases, suppose you are giving 100 words, or even I would say here in this case 50 words, model is totally gonna screw up. And what is the reason for it? Because RNNs tend to forget. It's like Ghazni. It has some limitation, na? Ghazni has limitation of how much time? 15 minutes, right? So it has limitation in terms of short-term memory. So RNN tends to forget the earlier information due to their short-term memory capacity. This is the model drawback. Now you can always question me, prove that it has short-term memory like 1 MB. I can't prove that, guys. Then you have to go into the depth you have to go to 30,000 feet under the ocean, okay, which is not the scope. If you want, obviously I can also get crazy when I have to explain this, because that is not something so easy to explain. It has a short-term memory capacity. So what I'm trying to say, and that's the reason remedy is what? Who is going to save you? So the remedy is LSTM. Okay, that's where the topic. So model is not able to remember things, and to a point it has to do with this gradient issues, because long-term issue creates problem. So this model becomes like Ghazni. This is just a way to remember. Okay. Ruchika, we can say that when we have long sequences, then yeah, exactly my point. Yes, exactly. Now, what is the impact? So don't worry, vanishing gradient is something I'll go mathematically and tell you when we meet again. I think I did not discuss this. I have not done this. So impact on what kind of tasks? So tasks like language modeling, right? So language modeling means what? You have to actually read paragraphs, or topic modeling, right? Or understanding contextual meaning of a para, right? Suppose someone has given an abstract and they are saying, do you understand what is the gist of this? So suppose I give you an article of 200 words from a newspaper and I ask you that give me a headline for this news, right? Then this model would fail. Agree? Suppose you're working in a news agency and you're looking for some catchy headline. You need to understand the news, right? So generally people write the news and then they look for heading. You know that in journalism. So news headline has to be catchy, still capturing the essence of the article. So in this kind of work, these kind of models won't be able to useful. Won't be. The sequential nature is going to create issue, and that is something called lack of parallelization. Right? So lack of parallelization. So you know what? CNN, unlike other models, it can be processed in parallel. So Masrat. So unlike CNNs, where operations are where operations on different pixels can be processed in parallel, RNNs process one time step at a time, right? Isn't it? X of t, 0, 1, 2, right? So RNN process one time step at a time. You give one word, you give one big sentence, doesn't matter, but it will only process one time. Let me highlight, process one time step. So what is time step? This is your time step now, T0, T1 at a time, which prevents parallel processing. Now this is the issue. What is the impact? Impact is longer training time. Right? Training time will be longer, na? Dheere dheere. Longer training time and inefficient utilization of hardware. Suppose you have a nice GPU, paid some $10,000, but you're not able to use it because it doesn't allow parallelization, right? Not paralysis, parallelization. So it is going to be inefficient utilization of machines or hardware. I'll write machines. In bracket, I'll write hardware. So these are some top of my head, these are some issues.
Just a quick info, guys. Intellipaat offers artificial intelligence course training, which will enable you to learn skills like neural networks, focusing on CNNs, RNNs, and their application in AI, natural language processing, computer vision, and generative AI. Through this course, you will also master deep learning concepts, AI model building with TensorFlow, transformers, BERT, GPT, LangChain, and NLP pipelines with advanced techniques like image recognition, chatbot development, and much more, all taught by top 1% experts and IIT faculty. And with this course, we have already helped thousands of professionals make successful career transitions in AI and data science. You can check out the testimonials on our Achievers channel. The link is in the description below. And without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take your first step towards the dream career growth in the field of artificial intelligence.
Natural language processing, that's the topic. So I think I would like to start with this bullet point. NLP is one of the hottest areas in AI. You will be surprised to know that you have more jobs even with respect to jobs. Number of job openings. What is natural language processing? So natural language processing, NLP. I'm not talking about NLG. So natural language processing is a branch of AI. AI is artificial intelligence focused on enabling computers to understand, which I saw some of the guys have, few of the guys have written, understand, not only understand, we have to also ask them to interpret and respond to human language in a way that is both meaningful and useful. Now, this is a very important line, meaningful and useful. See, meaningful is one thing. So if I'm asking something, but you're saying something that has some meaning, but is it relevant for me, right? Suppose you ask Alexa or anything like that, right? Tell me something about air quality index. Air quality index, if I'm asking, right? What is the air quality in my area, for example, and I say in Bangalore. So let's say Alexa replies air quality index for Delhi is 300, right? Is it useful for me? It's meaningful, right? Obviously, Delhi air quality index is telling me it has some meaning to it. But is it useful for me? No. Relevance is the key, right? I want to know the cricket score for India team. They are telling out it's telling something else. So that's why it's very important that machine needs to understand. See, first thing is that understand. Then machine can interpret what I'm asking so that it can respond, right? See, it's all in like sequence. If machine cannot interpret, can it respond to it? No, there's no way. Understand, respond. So this is step 1, followed by step 2, and this is step 3, right? So any time when you're explaining NLP to anybody in this world, you have to come to this part of the definition. Understand, interpret, and respond, right? Now you might be thinking, Akash, what about NLG? Obviously, when the machine responds, it does the NLG. So it's like implicit definition of NLG is already being captured here. Suppose if I am talking to Alexa, correct? Yeah, it's so guys, again, no marketing intended. Okay, suppose I say something to Alexa, right? Same question. So I'm asking, yeah, Alexa, Siri, whatever, what's the air quality index in Bangalore? Let's say I ask a general question. Alexa says, air quality index for Delhi is 380, whatever. So definitely this is not relevant for me, right? Why I'm putting a cross? Because it's not relevant. But it is meaningful. It has the correctness to it. It has some meaning. Let's say Alexa says, okay, good. Obviously, I'll say, Alexa, what are you doing? Right? Tell me for Bangalore. So let's say air quality for Bangalore is 150. So now, between these two things, right? These two conversation, right? There must be few things going on, right? Obviously, I ask a question to Alexa. Alexa, understand, interpret, and respond. Till the time it processes and understand, respond, right? Everything comes under NLP, right? Even generation has that. But definitely here, Alexa has generated something, right? Do you see, guys, what I mean by that? When I say that, Alexa has generated the natural language. So when Alexa talks to you, Alexa is doing what? Right? Alexa is doing NLG. NLG is another terminology. So it is natural language generation. This is NLG definition. One more line which I want to write. NLP mathematically, if you think, sorry, from deep learning and machine learning side, if you see, NLP combines computational linguistics. Now, this is a new terminology for a lot of people here, right? Computational linguistics with ML AI models, right? So everybody started with ML, then moved on to AI to process and analyze large amounts of data. And trust me, text is something like large amounts of data. Now, though, ChatGPT is like with the LLM models. Okay, let me talk about it, guys. Shall I talk about computational linguistics? So, any college you have studied, right? There must be a linguistic community, right? So don't think it's like. So similarly, when we are building this NLP, later on they coined this term called computational linguistics. Now there is no poet, there is no author. Everything is a machine. That's what computational comes into the picture, right? So it is an interdisciplinary field. Interdisciplinary field that combines linguistics and computer science. So these are two things that combine, linguistic and computer science, to model and analyze human language. Let's talk about some key areas in this field. So what could be the key areas? I think one which I feel is very much in demand is language modeling. Topic modeling is one of the key areas within this language modeling. So let's understand what is language modeling. What is the objective of language modeling area? So those who are working in this field, their objective is to predict the probability of a sequence of words. Predict the probability of a sequence of words. So I think smart compose is a little far-fetched here, but examples like, speech recognition. Guys, speech recognition, when we speak something, it writes, right? It types. Have you done this in your phone? Rather than typing, you just say something and it types for you, right? Or TV or Alexa remote, right? Speech recognition is transcription, right? So speech recognition, also known as ASR. ASR is what? Automatic speech recognition. That's why I'm totally against the idea of jumping to build something without knowing the foundation. So guys, what it does, speech recognition, it is a technology, right? Converts spoken language into written text. That's it, nothing else. I don't know how many of you guys have done this. So when I have to do something, I have to write it out, a lot of content, right? I don't type. So those who are having a Microsoft PowerPoint, so in consulting, we have to make a lot of slides. So we think a lot. So whatever we think, we talk. So what we do, either we use PowerPoint to capture it. PowerPoint has a dictation, you know that? So I've used this service a lot. I'm a big fan of it. It does a good job, by the way. So if you want to increase your productivity, you have to go to the PowerPoint, just take a text box and do it. I'll make it a little more bigger. Can you see a mic button there? Dictate, it says, come on. So this dictate thing is it will dictate. So you have to just talk through any of your mics. And trust me, it's really good. I have tried it and tested it for a few years. Whenever I think it got launched, I forgot, but yeah, you can also use it. Now there are a lot of apps which can capture, you can use your phone. Okay, so that was one of the key areas. I think language modeling, right? Within that, I took an example of speech recognition. Moving on. Okay, number 2 is your text generation. Now, text generation is, what is text generation? Another big area. Text generation and machine translation. Two things. I think ChatGPT, right, which is coming, right? It involves creating, right, new coherent, means fluid, with fluency, and contextually relevant text, not some random text. If you're able to, or you're doing these kind of things based on a given prompt, that's where I think NLP has branched out from here and gotten deeper and deeper, right? So a lot of architectures are being used here. So for example, common architectures include, always remember guys, the starting point was NLP. Remember that, don't forget it. So common architectures include RNN models. We have studied recurrent neural network. This was the baby stuff, but at that time it was a big thing. Obviously, LSTM and transformers, long, short-term memory, which is LSTM, and transformers like GPT. Now, another big area is what? Machine translation. Machine translation. Okay. What do you mean by machine translation? Answering your queries on the chatbots, text generation. So this is like a world in itself. So this thing, so obviously it's a world in itself. But that doesn't mean that you will be just using it. I'm also talking about what we should do. That's my job here. Okay. How many of you guys remember more than 10 mobile numbers? No, my aunt, she is like 75, right? 70 or 75. At least she knows numbers of 50 plus people. She has this Nokia button phone, right? She just dial from her memory. So what I'm trying to say, we should not be in a situation where we have to search our own names in Google, or you have to ask, okay, tell me my dad number, Siri, or call Siri. So what I'm trying to say that human has to understand, if everybody machine will do, our ability to perform or compete with them will also degrade. So that's why don't ever write mails using that device, the ChatGPT, whatever you have, or Copilot. Always reply your own mails, right? Machine translation. It is the process of, like Google translation, right? So it is the process of automatically text conversion or translating, of automatically translating text from one language to another language. Obviously, it's not that simple. It requires quite a few things, right? So it requires understanding the syntax. Now just imagine that if I'm saying something and generating that in Tamil for, right? I need to get the syntax right. I need to get the grammar right. I need to get the semantics right. And not only the source of both source and target language. Suppose I'm saying English and it has to be translated into Tamil. Earlier it used to take a lot of time, right? But now I can teach in Tamil. You know that? So those who are like native speaker of Tamil, right? Tamil Nadu, anybody who is living outside Tamil Nadu, but they only know Tamil, no other language, I can still teach them to deep learning without knowing Tamil. That's the problem, that people don't learn a lot of languages. Accurate and fluent translation. Let ChatGPT talk to me in that language. Suppose I'll give a script. It involves creating new coherent contextually relevant text based on a given prompt. Generate Tamil text for it and also the pronunciation, right? And I have to practice and then I have to speak. I have to still dub it, right? It cannot directly get converted into Tamil. I need to check. Maybe some paid uh, models can do it. I have seen. Guys, let's talk about a little bit. It's all mathematics. I don't know. So those who have done signal processing, they know. Suppose I say, so whenever I join this class, right, I say hello guys. So I do say hello guys. And I ask this question, how are you? Right? Isn't it? So when the moment you say the word hello, right, every letter has its own way of sounding, right? Hello, right? Hello. It's a speech. But if you try to show this, right? So when I say hello, it's an analog signal. It's a continuous signal in time. So this is my, let's hypothetically, I'm saying, I'm not teaching you like signal system and signal processing here. So let's say this is your hello, and this is your analog signal, XT. Analog is like your, remember that analog, digital, they were used to like, different types of devices, analog transmission, digital transmission. So it's an analog signal. When I say hello, obviously hello is like a speech, human speech, right? It's my voice. Hello is my voice, right? Machine cannot understand voice. That's why it has to get converted into a audio signal. So what you're seeing here, guys, is your audio signal is an analog signal. And to convert this into speech to audio, there's a device called transducer. Those who have done engineering, they might have heard about it. Trust me, this is exactly even machine is doing today. Transducer, it converts one signal to the other form, right? So speech is my speech. It comes from my throat, right? That's why those are speaking different language. There were different ways of moving the tongue around their mouth, within their mouth, right? It touched the upper side, so depends on the word and the pronunciation, right? So God has created that. So we have this gland, pharynx, I remember. Then we have this throat, vocal cord, tongue, teeth. Everybody has a role to play when you speak. Trust me on that. Yeah, larynx. Transducer, in simple, audio signal is like electrical signal. So guys, what I'm saying here is that, have you seen a loudspeaker? Like I know a lot of people have seen a PA system. What is PA system? Everybody has seen in the college. So I would like a moment to explain this whole thing. So PA system is something you have seen it. You go to a party or DJ or whatever, right? You must have seen a PA system. Trust me on that. Not obviously like a big PA system or DJ system, but at least everybody has this. So if you see here, there is a microphone, right? So let's say I am trying to talk to you guys. Obviously, I can't sing. I'm a terrible singer. I'm a terrible comedian. Means my lame joke, nobody. But let's say really I could give some gyan, right? That's my forte. That's my skill. So suppose there is a mic and this guy is trying to do something, right? The moment we say something, let's say here I said here, hello. I just say hello very quietly, not loud, not shouting. Hello. This hello goes where? This hello goes into this microphone first. Microphone, it's a short for microphone. Microphone is a transducer. Let's talk a little bit of engineering here, and you will love. So guys, I've done electronics, right? You remember this? So when I teach communication system, right? I mean, I used to like, trust me, I used to like control the whole class communication system, and I used to teach like it's still a hit. So hello, microphone transducer. What it does, microphone is a transducer, guys. Listen to me. So where is the microphone? Let me highlight. This is the microphone. Huh? So microphone is a transducer. So what it will do, guys? it will convert, this microphone will convert speech into electrical signal. So you can say that speech or voice to audio, which is your electrical signal. So let's call this audio. Audio is your electrical signal, Shania, not the other way around. Audio and electrical is same, right? Now, once you're done, then you have seen it, right? This microphone will be connecting to either wirelessly or whatever, but will be connecting to this part. What is this box? This is a very famous box, amplifier, right? And then you see this is your loudspeaker. Guys, loudspeaker is also a transducer. This is also a transducer. So now what machine does now, and you will love it. So what it does, if I say a hello, let's say this is the voice for hello. This is the waveform it has created for hello. But when I say hello to a room full of 400 people, I say hello, but you will hear or you will listen hello, right? You understand the difference? I say hello and you hear like hello. So, you know, this power has come to my voice because of the amplifier. See, so it becomes bigger and waveform is same. So when it goes to the mic, who is making this magic happening here, guys? So this hello becomes in waveform, you will see a big hello is coming to you. But who is making this happen, my dear? Amplifier, X. So it is called transmitter, receiver. Now when I say hello, then loudspeaker, you think loudspeaker is doing this. No, loudspeaker is doing nothing. Loudspeaker is not making this hello bigger, right? Amplifier is doing it. What loudspeaker is doing it, loudspeaker is being connected to these two guys, it just transmits, but again convert back into your voice. That's the power it has. So guys, you cannot understand electrical signal. If I say hello and then it gets converted into electrical signal, which is this, you will say zzz, some electrical vibration will be there, but it has to get converted back to hello, but amplified hello. So this is another transducer, my dear. It converts the amplified audio signal into, again, come on, into speech signal, which is another amplified. Moving it hollow, and you understand that hollow is going to come out of the loudspeaker. Now understand, obviously machine is taking care of this part, but what I was trying to make a point here is that you should understand the science behind it. So when you're writing something or talking to Alexa, Alexa is doing all those things, my dear, on top of machine learning. So that's what I'm saying now. So it is combining what? It is combining linguistic, computer science, but generally people say computer science is everything, but nobody. Electrical and electronics engineering is also happening. So those who are electrical and electronics engineer in this session, they should be proud about it that computer science is nothing without us. You guys agree? As a matter of fact, when you go to MIT, there's no such different departments. In MIT, they call it computer and electrical science engineering. You know that? In India, it has different streams, right? But MIT, if you see, right, MIT says electrical and computer. So computer came later. It's electrical and computer science engineering. I don't know how many of you guys are aware of it, but there used to be like this. So MIT is all about this. Let me show you this so that you don't take me for lightly. So this is and those who want to study, obviously you will have kids, I'll have kids whenever God knows. But, right. So down the line, you should know that all these things are related. Guys, can you see this? So this is like some awareness. I mean, electrical engineering, computer science, AI, decision making, all three, they have combined into one department. Obviously, it's one of the top-notch colleges across the globe. So yes. So I told you NLP, NLG all are related. So NLP has this big segment, which is your natural language processing. And this has two branches to it. So one is There's no video, so we're not worried about it. So already I introduced this, but now I'm going to build on top of it. So I'll say one is your natural language understanding, NLU, natural language understanding. Which is NLU. So NLU is not something which you don't know. I just explained that, just jotting down quickly so that you are not clueless. So NLU is the process. It's not in the scope altogether. So it is the process of which you have already seen, right? Me doing analyzing and understanding. I'll just keep it short. The meaning and intent behind human language. Intent is more like your context. It focuses on comprehension, interpretation, and extracting meaning from the text or speech. So when I say speech, means you can also analyze your audio now, right? But our course is more on the text. So I'll be sharing the US sentiment, US airline data to work on it. That's where we are going to do the more like the hands-on guys. I'll just highlight here. But as a matter of fact, you can also do speech analysis. There are a few techniques which I think generally people want to get into it. So I think so one is sentiment analysis. I think now this has become one of the biggest area within this field. Trust me, sentiment is everything, right? So if you're able to crawl data from web and read sentiments of your consumer, that can be like amazing tool in sales and marketing. Agree? I'm not able to write techniques. Even you generate feedback for me, isn't it, guys? You give me feedbacks, right? So feedbacks are so important. Feedbacks are so important that if taken in a constructive manner and given in a constructive manner and taken seriously, it can definitely change the way we work. So anything which we are generating sentiment about it. For example, movies get released, right? Isn't it people are writing about it here, there, everywhere, right? I work for a lot of the top retailers in the world, right? Consumers, grasping consumer sentiment is like everything. And I'm not exaggerating with my voice modulation. It's every damn thing. You can get a product fully wrong if you're not able to read your consumer mind. How will you read our consumer mind? There's nothing like you're connecting a SIM or Neuralink chip to everybody, right? So how can you do it? You have to grasp, you have to capture their sentiments across the social media platforms. As a matter of fact, now comment, feedbacks, share your thoughts is like a common feature in all the websites in the world. Trust me. So if you're able to do some real nice work on that, and that's where your data is so important, right? One way is to capture the sentiment if they are sharing, right? But before that, people used to capture the consumer behavior by looking at their buying pattern. So you remember, Srini, when I was teaching the clustering, right? I don't know, did I teach you clustering or not? Because I came somewhere in the middle. So market basket segmentation, or finding the, uh, you know, customer behavior, looking at the demographic data, what they are buying. There, I also talked about the Walmart beer use case, right? So the segmentation, basketing the or grouping the customers on their interest, buying pattern, what they're doing with within your store tells more than you know. It's just that you need a real guy who can analyze the data and make some real insights, take some real insights from there. Now there are two things. One is that buying pattern is historical, sentiment is in real time, right? And looking at the way consumer behaves today, trust me, and I'm also a consumer, I'm also a customer. I'm planning to go to Kurg and suddenly I'll go to Munnar. Who can predict this? You understand what I'm saying? It's impossible, right? So it depends on 10 different things, and it's not all everything can be programmed and put into a model. So that's why someone will do in real time, and cookies is more to blame for, right? So these guys who are running this company like Make My Trip, Go Ibibo, Clear Trip, and likes of those, right? They so much play with your money with respect to your flight pricing. Trust me. But if you're not careful, right, you will always end up paying more. Trust me on that. You have seen that, guys. Suddenly your flight price increases, and you are like, what? By 800 rupees, by 1000 rupees per passenger, and you're like, what? Because they are tapping you. They know that you are looking for a flight. They also know that, right? You really need a flight. Okay. So I don't know, means tech has come so far. If I don't complete a process on one app, they will start messaging me on WhatsApp. Oh, you have left your flight, complete it. Please come complete it, right? They will even call you. So the new companies will call you and say, Akash, I think you left in the middle. I said, yes, you're charging me more, right? So, so the point is that now customers also know their, I think forget about these things. Let's talk about Rapido, Uber, Ola, right? Come on, guys. Everybody using cab. Let's not take some hi-fi example. So every day we do this where we are getting a cheaper cab. Hello, yes or no? You also book three, they also accept three, and then they will decide where to go, right? This is how it's working. At least in Bangalore, this is how it's working. So Rapido is like a betting system, right? So you have to bidding system, sorry, wrong word, bidding system. So if you are bidding more, they'll give you, you will get a car faster than anybody else. So suppose a normal route cost you from origin to destination 400 rupees, and you say, I'll give 500, dude, come please sit. You know, so if you're busy, you don't care for 100 extra bucks, you're not worried about it, pay and go. I've done it multiple times. What to do, right? Obviously, not something I would like to do, but what to do. So, guys, just understand that how they're tapping the customer sentiment. So, those who want to make a career in this field, they can study sales and marketing. And there's a very nice book on the marketing research, right? I'm forgetting the author's name, but in case you need to know and you're interested in that, please, this is like a very fulfilling career. But join a very good company, because sales and marketing can be very toxic job to be in. Trust me on that. Especially the sales, not the marketing. Marketing is like, okay, you can do any ad, you can do anything, but targets and all you have to meet, so it's very tricky, competitive. Okay. But by that, everything is competitive in this world. So that is something and watch out for you. And there you can use a lot of, so Salesforce is uh, one of the one of the biggest tool in this world, right? So I feel, if you're aware or not, Salesforce is one of the biggest platform for this. Uh, and I feel that this is the way you can learn these techniques. So coming back to our topic of interest, which is your sentiment analysis, I'll talk about in this detail what is sentiment analysis, but I given one liner for it. So you go to a movie, you watch a movie, and you share your sentiment on Book My Show or IMDb, right? So generally you write some review and then you give a rating, right? Out of 5, out of 10. So basically, this analysis, this technique is all about determining the sentiment Now, sentiment can be positive. Positive also has a lot of levels, negative and neutral. So some of the guys in my class, learners, they'll say Akash is okay, and that's neutral. Akash is good, really good, excellent, positive. I don't think he's good, right? He's a bad trainer, negative. I'm just taking, on me. So same class, same set of learners, they will have different sentiment about a one person. Similarly for a movie, similarly for a product. Like a lot of people will be iPhone lovers, right? A lot of people will be like Samsung lovers. And that's why there is a page on Instagram where Samsung guys keep trolling iPhone guys. And trust me, even my workplace people are sharing me the links of the Instagram because I use iPhone and they keep sharing that see this, right? Means it's okay. Uh, but you understand, it's like a war out there. So India lost a match against New Zealand. Sentiments are pouring from all the places. Now, even government, like the political parties are using data like anything. You know that, right? I don't get political here, but I'm saying that they're also using AI. They're also understanding the people's sentiment. They are doing survey, and that's how they get the exit poll right most of the time, right? If they're not, rigging it. Good. So that's how it is. That is your sentiment analysis. Then one is like named entity recognition or entity recognition. So this came up pretty late, but this has come and revolutionized the way we look at NLP. So this is like I was talking about the other day, identifying entities like names, location, date in a sentence. So now with this, models are there which help you to understand, because if you understand that this is a name, this is the location, you can have a better contextual understanding of the sentence. Agree? And I will not deep dive on this because I had already shown you this in here. I don't know if you guys remember or not, but I'll show you that I was taking this example, Steve Jobs example, right? Did I take that Steve Jobs example? I think I did it. I did it, right, guys? I'm not able to find, but I did take the Steve Jobs example. I think I did here. See, Apple is looking at, right? So go through that. That's the same thing. Let's quickly talk about natural language generation, guys. NLG. What if you want to pursue your career in this field? But without knowing NLP, NLU, so you need to know NLU, then only you can be better in NLG, right? So there's no shortcut. But right, it is the process of generating, let me write quickly, human-like text. Now, though, we are also generating speech. So I'll write it from structured data. It focuses on producing understandable and coherent text that combines, that communicates the desired information. So there's a very good company called Automated Insights. I don't know how many of you are aware. So I applied this plugin in Tableau in one of the projects. So what it does, guys, it reads the data behind the chart and give you summary. So generally we look at the chart, take a screenshot and write the summary, isn't it, guys? Come on, right? What it does, right? It will give you summary of the same chart for different department heads. So if there is a sales representative, it will generate chat like a summary or generate text, right? More for this guy who is viewing this chart, right? So in Tableau, you can have the role-based access, even in Power BI. So for Mr. Mitchell, Donald, Donald Mitchell, right? Donald Mitchell, you can clearly see that he's getting 61%, right? Missing on target, whatever. So it will give you the full summary of what you're doing, right? Then head of sales will see more like a summary across the different sales representative, and sales manager will be like having a different view to it. So this is interesting, guys. Do you like it? I don't know. You are also going to be taught Power BI, or you must have been taught Power BI, but I don't know if your trainer did touch upon this topic that even